All right, so this is going to be a recording of this first part of this sample test. So the first thing that you are going to be required to do is fill out the unit circle, so you need to be prepared to do that. Let's see, I'm going to go through how these points work again. Let's kind of look over that a little bit. All right, so one of the things that I said is start by getting these points right here. You have a unit circle, that means this is over 1, up 0. This would be -1, 0. This point would be 0, 1. That point would be 0, -1. Okay, now you got to get these 3 points right here. If you get these 3 points right here, everything else falls into place. So the way I say is to make x get bigger. 1, 2, 3. The x values are getting bigger. Okay, make the y values get bigger. 1, 2, 3. Okay, divide everything by 2. Like that. Then don't forget to do the square root of the numerator. So square root of 3, square root of 2, square root of 2, square root of 3. There's your 3 points. That's all it takes to get those points. And then what you can do to get the rest of these points, just move them over. So this point, when you move it over, the x value just goes to negative. So that'll be -1/2 square root of 3 over 2. This next point will be negative square root of 2 over 2, square root of 2 over 2. And then this point, move it over, the x value changes to negative, so that's negative square root of 3 over 2, 1/2, like that. Okay, reflect these points over the x-axis. This point is going to change the y value, so it's going to be square root of 3 over 2, then the y value goes to negative. Same thing at this point, reflect it down, x value stays the same, y value goes to opposite. Okay, the same thing at this point, reflect it, x value stays the same, y value goes to an opposite like this. Now if you reflect these points over the y-axis, it's the x's that are going to change now. So you'd have negative square root of 3 over 2, same y value, reflect this one, that'll be negative square root of 2 over 2, same y value. Okay, then this one reflects over here, -1/2, same y value like that. So you can get those points like that. So you want to be able to come up with those points just in a couple of minutes like that. Okay, now let's look a little bit at the angles here. And let's see if we remember how to create these. Okay. All right, well, let's see. First of all, one thing that you can always do on these if you want to is you can count by 45 degrees. Okay, so I'm just going to go through and circle these, and we're going to count these out like this. Okay, so we're going to go, if you remember that pi over 4 is 45 degrees, and that's all you got to remember. So we just go 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, whoops, 6 pi over 4, 7 pi over 4, and all the way up to 8 pi over 4. Now I'm going to reduce all these fractions. So I'm going to have, of course, 0 radians there, pi over 4 here. Okay, 2 pi over 4 is really pi over 2 when you reduce it. 3 pi over 4 becomes this angle. Okay, 4 pi over 4 becomes this angle. Of course, you reduce that to pi. Then you have 5 pi over 4. And you have 6 pi over 4, which is really 3 pi over 2. Okay, then you have 7 pi over 4. Like this. Then 8 pi over 4, of course, is back to 2 pi again like that. All right, so that's how you can get the 45 degree angles then. Okay. Now the next thing you can do is you can go through and you can count by 30 degree increments if you want to, like this. So let's do that. Okay, if you remember that this is 1 pi over 6, then we just count out the rest of them. Now we disregard the 45 degree angles when we do this, so I'm just going to kind of block this off, block that off, block that off, and block that off. Okay, so I'm going to go 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, this becomes 4 pi over 6, which reduces to 2 pi over 3, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6, like that. Okay, so that's one way to do that. It's just count those things out. Kind of like that. There's other patterns you can see on this too. One thing that you guys might want to pay attention to on this is also kind of cool is notice these angles right here go pi over 3, 2 pi over 3, 4 pi over 3, and then this one is 5 pi over 3 is what that one's supposed to be, like that. Then the 6's, you go 1 pi over 6, 5 pi over 6, 7, 11. So whatever patterns you see is fine, but you want to be able to come up with that unit circle. Okay, so the next thing I want to do is I want to look just a little bit at if you're looking at a unit circle. So let's look at, for instance, the cosine of 4 pi over 3. Okay, part A. If you find 4 pi over 3 is this angle, the cosine is nothing more than the x value. So that means the answer to this problem is going to be -1/2. Okay? If you're looking for a sine, okay, the sine is going to be 11 pi over 6, find the angle. Now the sine is the y value. So that means the answer to that problem is going to be the y value. So coincidentally, that's just -1/2 also. Okay? Now if we want to do the secant is the reciprocal of the cosine. So one thing you can do on this is, first of all, look at your -45 angle. That's a clockwise angle, so it would go there. So you're actually looking at this point right here. So that means the cosine is the x value. So that means the secant is the reciprocal of that. So that's 2 over √2. Then you can rationalize that denominator like this to get 2 √2 over 2. That crosses out. So the answer to that problem is square root of 2. Okay? Now, if you look at cotangent of 10 pi, well, the thing that you want to realize is this is 0. It's also 2 pi. It's also 4 pi, 6 pi, and so forth. So this is an even pi. So 100 pi is going to take you to this point on the unit circle. Okay? So the cotangent is x over y. So if you look at this point on the unit circle, you have x is 1, y is 0. So that means you are undefined right there. Okay? And then this pi over here is 1 pi, but it's also 3 pi. It's also 5 pi. So that is the odd pi's right there. Okay, so you want to be able to use the unit circle. First of all, you want to be able to create the unit circle, radian measure, and the points, and then be able to answer any question about the unit circle. Any of the 6 trig functions would be fair game on that. Okay, next page. All right, as we're going through the next thing here, we're going to do some conversions here. So if we're converting 240 to radian measure, okay, what we learned to do on this is you just simply multiply that by pi over 180. And then what you want to do is you want to reduce the fraction. Okay, so if we multiply that together, we would get 240 pi over 180. Of course, the zeros cross out, leaving you 24 pi over 18. Now what you can do is you can reduce this fraction by 6. Both of those numbers divide by 6. So it's going to give 4 pi over 3 as the solution to the problem. So that's just multiply by pi over 180 and reduce. Very simple thing to do. Okay, next problem we'll look at is I give you an x value and a y value. So I'm giving you a point on the unit circle. So x is equal to -3. I'm sorry, this is not a unit circle. So we need to find what the r value is. We need to find x, y, and r. So we know that x squared plus y squared equals r squared. So we would have x equals negative 3 squared. Y is 4. That's equal to r squared. So that's going to be 9 plus 16 equals r squared. So that's 25 equals r squared. So you do the square root of both sides. Technically, you always do a plus or minus, but a radius is always positive. So in this particular problem, what we would have then is we would have this information right here. Okay? So we just go to the definitions. The sine is y over r. Okay, so that would be 4/5. Okay, the cosine. The cosine's x over r. So that would be negative 3/5. Okay, the tangent is y over x. So that's going to be 4 over negative 3. Okay, well, it's a negative value. The best way to write that is just write that as negative 4/3 like that. Okay, you're not wrong if you don't write it that way. That's the best way, though. Okay, the secant is the reciprocal of the cosine. So that thing becomes negative 5/3. The cosecant is the reciprocal of the sine, so that becomes 5/4. And the cotangent's reciprocal of tangent, so that becomes negative 3/4. Okay? Guaranteed problem. Just I give you any point. Your job is to find the value of the 6 trig functions. That's a standard good way to test students on whether they know their definitions or not, as is number 4. All right, so number 4, what I'm doing on this is we're going to find the values of the remaining 5 functions, and I've given you 2 clues on the problem. First clue I gave you is this is the value of the cosecant, and I've given you the fact that the cosine of that same angle beta is positive. So what you can do is put these 2 things together to reason out what we have. So when you look at this statement that says the cosecant of beta equals negative 5/2, by definition, the secant is r over y. So that means in this problem, we don't know what x is, but we do know y is negative 2, and we know r is 5. So the reason is, remember, r is always positive, so that negative has to go with the 2. Okay, then it would be Pythagorean Theorem, so we're going to do x squared plus y squared equals r squared. So that's going to be x squared plus negative 2 squared equals 5 squared. So that is x squared plus 4 equals 25. That's x squared equals 25 minus 4. So that's x squared equals 21. Then we do a square root of both sides, so you get x equals plus or minus square root of 21. Okay, well, when you put these 2 conditions together, you can narrow down which quadrant you're in. So I usually recommend students do a chart kind of like this, okay? So what I'm going to do is I'm going to put check marks. Okay, the cosecant is negative 2 places, quadrant 3, quadrant 4. That's because it's r over y. R is always positive, but if y is negative, so that means you're down below in quadrant 3 and 4. Okay, then I give you the cosine is positive. Okay, so I'm going to do this. The cosine is positive here and there. Cosine's positive where x is positive. So what that's going to mean then is these 2 check marks blend together in quadrant 4. So that means that we are in quadrant 4 when we put this together now. Okay, so that is going to mean now that x, since we're in quadrant 4, is positive. So you're going to have positive square root of 21, like that. Okay, now it's just a matter of taking these definitions right here, plugging them into the definitions of the trig function. So the sine is y over r. Okay, y is going to be negative 2, r is 5. So the sine is negative 2/5. Okay, now we can go on to the cosine. The cosine is x over r. Okay, so if we do x over r, we're going to get square root of 21 over 5. So that gives the value of that. Okay, now we can go ahead and find the secant, because the secant is just the reciprocal of that. So that's going to give 5. Okay, that's supposed to be 5 right there. So it's 5 over square root of 21. Okay, you can go through and you can now rationalize that denominator. So if you multiply that by root 21 over root 21, what you're going to get is you're going to get 5 root 21 over 21. Like that. Okay, rationalize. Okay, tangent's y over x. So we have y is negative 2, x is root 21. So it's going to be negative 2 over root 21. Rationalize that denominator, you're going to get negative 2 times square root of 21 over 21. Like that. Then the cotangent's going to be x over y. So x is root 21. Y is negative 2. So you have a negative answer like that. Okay, so that's how you piece that one together then. Okay, now we'll get a little bit into the graphing. And next thing we want to look at is, on this problem, is I'm giving you just a function. We're going to figure out what the period is. Okay, so the period, for a cosine or a sine, the formula for the period is 2 pi over absolute value of omega. Omega is the number that's in front of x. So you're going to do 2 pi over 3 pi. The pi's cancel out, leaving you a period of 2/3. Okay? The amplitude is the absolute value of the number that's in front of the cosine. Okay, so what we're going to do on that is just take the absolute value of negative 2/3. So the answer to the amplitude is positive 2/3. Okay, the vertical translation is this number, so it's plus 3, so it's going to be up 3. If that was minus 3, it'd be down 3. Reflection, yes, there's a negative. So that means the answer to that is yes, that's going to reflect over the x-axis. So you want to be able to, any function, sine or cosine primarily, identify period, amplitude, any translations that we've learned how to do. So you want to be able to do that. Okay, number 6. Okay, we're going to look at the range on a couple of these things. Okay, so one of the things on 6a that's real helpful is that you understand what the graph of the tangent looks like. Okay, so the tangent basically goes like this. You have an asymptote at pi over 2 because the tangent's undefined. The reason the tangent's undefined at pi over 2 is because on a unit circle, if you have a pi over 2, y over x is undefined. Okay, then at pi over 4, the tangent takes on the y value of 1. The reason is because at pi over 4 on the unit circle, you have square root of 2 over square root of 2, so y over x is 1. Okay, at 0 radians, you have 0. Okay, the reason for that is because on a unit circle, you have a 0.10, y over x is 0. So the tangent sweeps up through those points like that and approaches the asymptote. Then negative pi over 2, by the same kind of argument, has a vertical asymptote. And then at negative pi over 4, the y value is equal to negative 1, like we learned. Okay, so the range is what y can be. Y can be anything. So like if you look at this tangent, the tangent gets infinitely high and it gets infinitely low. So it's going to range through all of the possible y values. So we just write on the range negative infinity to infinity. Like that. Okay, domain of the cosine. Okay, well, what does the cosine look like? There's a couple ways to look at this. When we learned about the cosine graph, excuse me, this went like this. So it's kind of important that you memorize the sine and cosine. So you want to remember that the cosine graph, excuse me, goes like this. Starts high, x-intercept, minimum, x-intercept like this, but remember it goes on forever. So this thing will just keep going forever in both directions. So that means the cosine, the domain of the cosine is all real numbers. Now if I wanted you to do the range of the cosine, the range of the cosine ranges from -1 to 1. Reason being, you have a smallest value of y and you have a highest value of y. Okay, like that. Okay? So the next problem, we're going to look at the range of this cosine on C. So the way I look at this is, if you have an amplitude, just kind of disregarding the 5, if you have an amplitude of 3, that means the minimum is going to be -3 and the max is going to be 3. However, this 5 takes you up 5. So what we're going to do on this is we're going to add 5 to the minimum and maximum, and then we get basically the new range. Okay, so that means the answer to this problem is going to be -3 plus 5 is 2, and then 3 plus 5 is 8. Okay, like that. So that's how you'd figure out the range. Okay, next problem. Okay, we want to be able to fill in this sign right here. So I can ask, on this number 6, I can ask all kinds of possibilities. Domain and range of any of the 6 trig functions is what I'm testing you on. It doesn't matter what they are, so you need to study them all. Okay, there's several ways that we learned how to do this, okay? One of the things that I taught you on this is like all students take calculus. Now you can do this or you can reason it out. This is a way that if you learn this statement, hey, how can you go wrong? So here's the idea. Okay, in quadrant 1, everything is positive. Okay, everything's positive. Okay, the S for students means that in quadrant 2, it's the sign that's positive. The other 2 functions are negative. Okay, then the T for take calculus means the tangent's positive in this quadrant. The other 2 are going to be negative. Okay, and then the C for calculus means cosine's positive. The other 2 are going to be negative. So that's how that goes. You can also reason this out this way if you prefer. I mean, this is the more mathematician way, okay? The cosine is x over r. So notice that x is positive when you're to the right. Okay, x is negative when you're to the left. Okay, so you can do that. Okay, now if you were to look at the value of the sine is y over r. Y is positive above the x-axis. So notice the sine bit was positive above, the sine is negative below. And then the tangent is opposite quadrants. So you can remember that way if you want to. All right, now let's go down and do this graph. So we're going to graph out the function y equals 2 cosine 1/2 x minus 3, and we're going to graph it on this interval. Okay, the first thing that you want to do on these kind of problems is you want to figure out all the key pieces of this, like the period, the amplitude, and all that. So let's start with the period. So the period, the general formula for a sine or cosine is 2 pi over omega. So that's 2 pi. Omega is the number in front of x. So we're going to do 2 pi divided by 1/2. And that's really 2 pi divided by 1/2. So that is 2 pi times 2. So that period is 4 pi. So every time 4 pi goes by, you're going to go through one cycle. Okay, the next important thing is how do you increment the x-axis? And sometimes on tests I ask for what that increment is. Of course, I'm grading it based on your graph anyway. So remember, when you do the increment, you take the period and you divide it by 4. So the period is 4 pi, we just found that. Divide by 4, so that means that increment is pi. So what that means is on your x-axis, you need to just mark off by pi. So we're going to go 1 pi, 2 pi, and you can go as far out as you want to. I'm just going to go to 4 pi. One of the things I said is if you count this increment out, when you get to the 4th one, you'll end up at the period, like this. Okay? And then we're going to just move on like this. And then we're going to look at the graph basically from negative 2 pi to 2 pi. So I'm going to be interested in looking at the graph from there to there. Okay. All right, so that's step one. Get the period, get the increment. Okay, step two, let's figure out what the amplitude is. Okay, the amplitude is the absolute value of the number in front of the cosine, which is 2. That means the amplitude's 2. So what that's going to do is it's going to stretch the waves up to a maximum of 2 and down to a minimum of negative 2, so we do that. Okay, and then the last thing on this problem is this minus 3 is going to take you down 3 units, like this. So what you can do on this problem, there's several ways to do this. One way to do this is like this, and all I'm requiring is that you just get the final answer without a calculator. So let's graph just y equals cosine of 1/2 x. No amplitude, no down transformation. Let's just focus on that. All right, so by changing the increment, we've worked with that 1/2 period. So the cosine, remember, starts high at 0, 1. Then it cycles through these points. So the quicker you get these points memorized, the faster you can do these graphs. Okay, so we're going to go ahead and do that. And I'm just going to kind of dash that in like this. Okay, now we're going to do stage 2. I'll pick another color, like say pretty blue. Okay, well what we're graphing now is we're graphing y equals 2 cosine 1/2 x minus 3. So you can just start at any point. You can start at the y value of this point. The y value of this point is 1. So you're really doing 2 times 1 minus 3. So you're multiplying 2 times the value of the cosine of 1/2 x minus 3. So 2 minus 3 is going to take that point now to negative 1. Okay, go to this point. This point has a y value of 0. So 2 times 0 minus 3 is going to take that point down now to negative 3. So that point stretches, and it also reflects like that. So you can kind of see as we're putting that together, that goes like this. Okay, this point, when we do this, okay, you're going to go like this. So this point has a y value of negative 1. So you're going to do 2 times negative 1 minus 3. So that's going to take you down to negative 5. So you're going to be down here somewhere kind of like this. Okay, I should have done a better job of drawing this thing out. Okay, then you can just do all the points from here then. So basically this y value times 2 is 0. 0 minus 3 moves down to minus 3. This point, multiply the y value by 2, you get 2. Go down 3, you're down to that point like there. So that's going to be kind of the maximum. Now you can just cycle through these points. You can predict where they're going to go because you've now got the pattern on this. And then you can sketch the rest like this. Okay, it's real hard to sketch this thing on this computer. So that would be what your cosine wave is. So you've basically moved everything down 3 after stretching the amplitude to 2. Okay. Okay, let's do a cotangent graph on number 9. Okay. All right, the first thing that you always want to do on this, if you have y equals cotangent of x, we said the period on this, we said, is pi. Okay, the period of the tangent and cotangent is pi. And when you do the increment of the x-axis, you always still do the same thing. You just take the period and you divide it by 4. So you're going to count these things out. So you got pi over 4. Then you got 2 pi over 4. 2 pi over 4 is really pi over 2. Then you got 3 pi over 4. Then you got 4 pi over 4, which takes you to pi like this. Now I think I want to change this problem so we just graph on the interval from negative pi to pi. Okay, like that. Okay, now I'm going to go backwards through this. Negative pi over 4. Negative pi over 2. Negative 3 pi over 4, and negative pi. Okay, now the tangent, we need to go up at least to 1. You can go up as high as you want to like this, so I'm going to go down just up to 4 and to -4 like this. Now what we're doing is we're just simply graphing the tangent. So one thing that you can always do is you can reason out whatever you need to on the unit circle. Okay, so for instance, if you're looking at the 0 radians, okay, remember the tangent's x over y. So if you're at 0 radians, you have 1 over 0, which means you have an asymptote. So what you'd end up having then is you would have a vertical asymptote on the tangent at x equals 0, so you're just shading in that y-axis like this, okay? Now see, we just go around this and kind of get our key points on there. So if you went to pi over 4 on a unit circle has the point square root of 2 over 2, 2, square root of 2 over 2. So if you worked out x over y on this, you would get 1. So that means the cotangent of pi over 4 is 1. Okay, if you go to 90 degrees, or pi over 2, you have the point 0, 1. So in this case, x over y is going to be 0 over 1, so it's going to be 0. So you have a point like that. And then if you went to 3 pi over 4, you're looking at the point negative square root of 2 over 2, square root of 2 over 2 like that. So that's going to have a y value of -1. And then when you get to pi, you're looking at the point -1 over 0. So x over y is -1 over 0, so you're undefined again. So that means that you have an asymptote like that. So you can memorize it. If you have it memorized, you can do this graph real fast. But remember, the unit circle is the god of trigonometry, like I keep saying. So you can get all the information from that unit circle. Now, if you just go on from here, you would also have an asymptote at -pi. Halfway in the middle, you have an x-intercept. 1 unit to the left, you have a y value of 1. 1 unit to the right, -1. And then just repeat that to get the second period of the cotangent wave like that. So that's how you graph cotangent. So you need to be prepared to do cotangent or tangent. I don't do anything other than, no period changes, but I might do something on a test. I might do something like 2 tangent of x minus 1 or something like that. Okay, not going to do much with period changes on that. We might do a little bit of that on the second exam. Okay, now what we're going to do is find the domain and the equations of the asymptotes. So it's always kind of helpful on the domain to find all the places where you're undefined and just list them. Okay, so we're undefined at 0, pi, -pi. And then what you want to do is sort of see if you can spot a pattern. So we're at 0, pi, 1 pi, -1 pi. So every pi, you're going to have an asymptote. And it's going to go on forever and ever and ever in both directions. So when you list the domain, you're telling me what x cannot be. You say the set of x, and x cannot be equal to. You can't list all these things, so you have to write a formula. So it always has a pi in it, but k is going to be an integer. So we say k pi, then we say k is a element of the integers, like that. So that's the answer. Okay, the equation of the vertical asymptotes is x equals k pi, with k being an integer. Okay, asymptotes are equations, so it's x equals something. So what you want to do is look for patterns. If you did the tangent, it would have a slightly different pattern, but it's something if you list out, you should be able to figure out. Okay, here's another graph, a secant. Okay, so going down to this number 10 now, we're going to be looking at graphing this. So if you're graphing y equals 2 secant of 2x, what you really need to focus on is graphing 2 cosine of 2x. Okay, so anytime you graph a secant, you want to graph a cosine. Anytime you do a cosecant, you want to graph a sine. So the first thing we want to do is we want to figure out what the period is. So if you're doing a cosine, the period is 2 pi over omega. So that's going to be 2 pi over 2, with omega being the number in front of x. So that's equal to pi. Okay, the increment of the x-axis, you always take the period, pi, and divide by 4. So then what you do is you count this out. We need to count this out on the x-axis. Go by pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Of course, reducing the fractions. Okay, and we're going to take that interval up to pi. Then we're going to go to the left, and we do like negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi like that. Okay, so that takes care of that, right? Just by re-incrementing the x-axis, you've taken care of the period change. Okay, now the amplitude is going to be equal to this number. So that's equal to 2. So that's going to tell you on this one that you need to make the y-axis go up to 2 and down to negative 2. But you want to make it go a little further because you are graphing the secant wave like this. Okay, so what you do on this then, and you can do this pretty much in one step if you want to, is the cosine. If we were just doing the graph of y equals cosine of 2x, well, that graph starts at the point 0, 1. But since we have an amplitude change, that point's going to move up there. Okay, the second point on a cosine is at that x-intercept. That is not changing. Then you're going to go down to your minimum, which is negative 2, back up to the x-intercept, and back to the maximum. So that would take you through basically one cycle of the cosine. Okay, then what you do is just kind of back up on this and do this like this. All right, so we get that taken care of like that. All right. Now, the next thing is we need to figure out where these asymptotes are. Okay, the vertical asymptotes are going to occur at places where the cosine is equal to 0. In other words, those are x-intercepts. So I'm highlighting where those asymptotes are going to go. Okay, so we're going to do that. We're going to go straight up. There's your vertical asymptote. Here's the second vertical asymptote. And then you have another asymptote at negative pi over 4. Like that. And you have a final asymptote right there. So you want to get all those asymptotes put together. You should put little arrows on those things technically. Okay, like that. Now, what we do is we just sketch the rest. I'm just going to use like a highlighting color, I guess, on this. Okay, so what we learned is it's kind of a U shape. So that would be one shape like that. And you would make one go like that, approaching the asymptotes, but not crossing them. You have the U shape goes there. A U shape that goes like that, and then a last one like that. So that would be the graph, the final product like that. Okay, so you want to be prepared to do a secant or cosecant with any type of transformation we've learned on. Okay, so the equation of the vertical asymptotes. Well, what's usually helpful on this is to just write them down. Okay, we have a vertical asymptote at pi over 4. We have another one at 3 pi over 4. Okay, we have another one at negative pi over 4. And we have another one at negative 3 pi over 4. So the question is, what is the pattern? Well, you could predict this pattern. The next one's going to go 5 pi over 4, 7 pi over 4, 9 pi over 4, and so forth. So what the thing is what's the pattern? Okay, first of all, they all have a pi over 4 in it. Then the other thing is they all have an integer in it. So 5, 7, 9, those are all examples of odd integers. So when you put the answer together, okay, give the equation of the asymptotes, it's x equals, and it's going to be k pi over 4, and then you just have to state that k is an odd integer, like that. Okay, so that's how you put that together. Okay. All right. So let's move on and do another graph and kind of finish up a couple other things. Okay, so on number 11, we're going to graph y equals negative 5 sine of 1/2 x So the first thing we're going to do is we're going to locate what the period is. Okay, the period is 2 pi over omega. So that's going to be 2 pi divided by 1/2, with 1/2 being this value right here. So that's 2 pi times 2 over 1. So that means the period on that's 4 pi. All right, so we have a period that's 4 pi. Next step is to find the increment. The increment, you always take the period and divide by 4. So you'll get pi as the increment. So when we do this increment, we're going to just count by pi. So it's pi, 2 pi, and then 3 pi, and then 4 pi like that. Okay, now we have an amplitude. The amplitude on this is absolute value of -5 or 5. So that means that we need to make the y-axis go up to 5 to incorporate the amplitude. Okay, like that. Now you can do this problem in 1 stage or 2 stages or 3 stages or whatever you want to. All I'm grading is the final stage. So the sine, there is no up-down transformation, so the sine starts there. Now I'm just going to graph out a basic sine wave like this, and then we're going to do this all in one step after we do this. All right, now this -5 right there, what that does is it multiplies all of the y values by -5, okay? So what I'm going to do on this is each one of these y values gets multiplied by -5. So this y value here is 0. -5 times 0 is still going to be 0. Okay, so that point stays the same. This point has a y value of 1. -5 times 1 gives -5. So that point moves all the way down there. This point has a y value of 0. -5 times 0 is still 0. This point has a y value of -1. So -5 times -1 takes you up to +5. Like this. Then this point would go back to 0. So now you can sketch the points in kind of like this. It's so hard to draw that on that pen. So it goes like that. You get the idea. Okay. All right. So that's kind of a standard period change, reflection, amplitude. Okay. So you can have any of the possibilities we've talked about in class. Okay. To finish this up now, what this number 12 is testing you on is the idea of a cofunction. Okay, so one thing that we learned is the sine and the cosine are cofunctions. So notice that 2 and 88 are complementary angles. So we learned that the sine of 2 degrees is the same as the cosine of its complement. And the way you find a complement is you subtract from 90, so it's 88. So those two things are the same. Notice also you have a tangent of 20 degrees. Well, the cofunction of the cotangent of the tangent is the cotangent. So the complement would be 90 minus 20, so it would be 70. Right? So what you have is these things, you have several things are equal. Okay, now you can do this kind of in your head, and you can do this in a number of different ways. I'm just going to not change the sine of 2 degrees. I'm going to leave that alone. But the cosine of 88 is the same as the sine of 2 degrees. So just replace that with sine of 2 degrees. Okay, they're the same. The sine of 2 and the cosine of 88 are the same number, so they're going to cancel out. Then this part of the problem, I'm going to leave the tangent alone. Okay, and I'm going to change the cotangent. The cotangent is the same as the tangent of 20 degrees. Okay, so that's how you get that thing worked out. Now what you would have is, of course, that would go to 0. This would, of course, be 1. So you have 0 plus 1 is 1. So the answer is 1. The way that you can know that you're dealing with cofunctions, of course, is the sine, cosine, tangent, cotangent. But also pay attention, one of the clues that you're being tested over this is these angles are complementary. 20 and 70 add up to 9, 88 and 2 add up to 90, like that. So that's the idea. Okay, and one last thing would be, you want to be sure that you can do conversions, to radians or backwards. two ways to do this. One way to do this is just remember that pi radians is equal to 180 degrees. Okay, so we just do 8 times 880 over 9. And then you got to be able to reduce your fraction without a calculator, whatever it takes. So 180 divided by 9 is 20. 9 divided by 9 is 1. So we have that. Now if you do 8 times 20, you're going to get an answer of 160 degrees like that. So you want to be able to just do basic conversions like that. Okay, now this test is intended to be an overview. It may not encompass everything on the test, so you want to look over some other information as well, but these are highlights. These are some of the definite things that you'll see on there. You're going to see variations. These are kind of the highlights that we've learned from section 7.1 to 7.7. So that will be the end of this. Hopefully this will help you to study and prepare for the test. Good luck.